The term greenwashing was coined back in 1983 by environmentalist Jay Westerfeld while surfing in Fiji. He later published an essay in 1986 titled, "It All Comes Out in the Greenwash," highlighting how companies were making misleading claims about their environmental practices. Fast forward to today, greenwashing has become a sophisticated art form and big business, with some of the world's largest corporations caught in the act. Whether through misleading marketing in examples like Volkswagen, BP, Nestle, and Fiji Water, or in financial manipulation used by hedge funds and inconsistency among ratings agencies, it's clear the line between genuine sustainability and greenwashing can often be blurred. One bright spot in the haze is the emergence of modern building efficiency standards that are reimagining actual sustainability goals. Standards like LEED, BREEAM, Net Zero Energy Building, and the Living Building Challenge set rigorous criteria for energy efficiency, water conservation, and overall environmental impact. These standards all contribute to a major challenge for sustainability: last mile power. Last mile power refers to the final stage of the electricity delivery process from the power distribution network to the end users, such as homes, businesses, and other facilities. This term is borrowed from telecommunications, where last mile describes the final leg of the network that delivers services to customers. In the context of power delivery, it involves the infrastructure and technologies that ensure electricity reaches its final destination efficiently and reliably. Greenfield construction projects benefit from these new standards where everything can be designed from scratch. But what about brownfield solutions for the last mile? That's where modern technology solutions like Power over Ethernet, or PoE, can make a real impact on efficiency and reliability without resorting to manipulation to achieve sustainability targets. Where simple modifications using existing infrastructure can make a big impact. How can microchip technology prevent greenwashing through real, tangible sustainability solutions? Let's go beyond the microchip and hear a story of empowering innovation to enhance the human experience. Returning to the podcast is Alan Zwirin. Alan, a senior product marketing manager at Microchip Technology, specializing in power over Ethernet solutions. He joins us today from Tel Aviv, Israel. Welcome back, Alan. Thank you for returning to Beyond the Microchip. In the intro, we introduced a few discussion points about greenwashing. This is something we see a lot in the headlines, but there's a good chance the term and its movement are misunderstood for a variety of reasons. What are your thoughts on that?
Well, first of all, thank you for having me back. It's great to be here. And, you explained that greenwashing was first introduced by Jay Westerfeld. It's interesting. He was an ecologist who was actually surfing in Fiji, and he went to a hotel and he came up with the term greenwashing because he saw them tearing down pristine nature next to his hotel for expansion. Yet in his hotel room, there was a sign, please reuse the towels so that we can save the environment. So, I think that greenwashing is very much a misunderstood concept, but it's also become a concept that has been played on by many marketing executives. Mm-hmm. They want to make certain that they're perceived as being ecologically appropriate, I guess is the best way. And basically, everybody tries to put a greenwashing or a sustainability label, an ecological label on things. And I really think that it's becoming a real big problem today, especially in our business community, because every company you see will have something on sustainability or what they call ESG, and that stands for environmental, social, and governance standards, to prove that they're trying to do the right thing. But the proof is really in the action. It's not in what you're putting up on your website.
Yeah, it's a standard marketing tactic for companies to say, I'm hip, I'm with the zeitgeist, we're keeping to the trend. And the danger of that is the second that any kind of poke holes in it, you get a backlash. And then the backlash usually means that somebody will deliberately not invest in a company because of their ESG rating, and then you lose the spirit of the entire thing.
Well, you talk about ESG ratings, that's another gimmick almost, if you will, that financial institutions use to try to demonstrate their credentials. but there are over 600 rating. There are over 600 rating agencies today, and not one of them is the same as the other. They all use different standards, and they're doing them to try to sell you stock. They're not doing them to try to say that this is good for the environment. You might find one or two agencies that are doing that, but the majority of them are doing this as a ploy to sell you stock. There's no consistency. There's no methodology.
Yeah, by and large, it's a measurement of risk, right? So Chevron has a good ESG rating based on a set of weighted criteria, which you wouldn't think that an oil company would be associated with environmental stewardship. But again, see above 600. What are some other examples we can talk about?
Well, when you said Chevron, BP came to my mind. Besides having
British
a big
Petroleum.
ecological, besides having a big biological disaster in the Gulf of Mexico, right after that, they started a campaign that BP stood for Beyond Petroleum. And they are trying to make this move to say that they are going into green energy, and yet over 90% of their revenues today still come from petroleum, And it's not only that, very, very popular is Fiji Water. From a natural source, everything great.
Got that nice square bottle.
It's packaged in plastic bottles, and you have to ship it all around the world instead of using a local water source to deliver fancy water to you. By plane, by ship, by something that's consuming, a gas or oil to propel it, which is definitely not green. So there are a host of them. Volkswagen has a very famous scandal for showing that their cars were energy efficient. However, it turned out that the measuring devices that they were using were just rigged to make sure that they said that they were energy efficient.
Cheating on their emissions, Yep. Yeah, there's a parable or a heuristic that I'm thinking of where once the good measure becomes a target, it ceases to become a good measure, because then people start doing everything to hit it, and rather than focus on measuring it, they actually try and game the system to hit it.
Well, I think the big thing about trying to ascertain if somebody is actually truly being green is the transparency that they do. Are they publishing what they're doing, good and bad?
Right.
And, then are they getting feedback from what's going on? And are they trying to adjust and improve themselves? In Microchip, we have a value of continuous improvement. But, if you're saying you're green, but you're not measuring it, you're not reporting on it, and you're not doing anything to improve it constantly, then are you really being green?
Right. Yeah, we have a sustainability team at Microchip that focuses on how can we reduce consumption of resources. And we started out with how can we reduce consumption of natural resources, and that means we're not actively pulling things out of the ground. But then we broadened it to be how can we reduce consumption of resources in general. So not only can we not pull it out of the ground, we can't then go get somebody else who pulled it out of the ground. And so how much can we reduce, reuse, and recycle? And a lot of it has to do with water, but that's not the only measure that I'm aware of in our sustainability efforts. But we're mostly talking about the E in ESG, right? We're talking about the environmental impact.
Yeah, so there's important to understand within the whole corporate sustainability movement, there are corporate governances that go beyond just energy or waste or gas emissions. And that has to do with creating an environment within the community that you're in to make sure that you're not impacting the environment, and that you're not only not impacting it from a pollution or product waste perspective, but you're giving your employees a living wage. You're also making sure that they can have a decent existence. Things like that are a part of all this ESG. But for what we're talking about, especially with greenwashing, it is the sustainability that you're looking at. And, you mentioned things that are involved in it. It's not only energy efficiency and reducing waste, it's also water conservation. It's also reducing greenhouse gases. And if you can't reduce greenhouse gases, what other actions can you take so that you can consume some of those greenhouse gases that you are producing And then it's looking at your production. It's looking at not only how are you making things, but how are you getting the materials to make things to there to reduce the impact as far as possible. I don't know if you've ever been to Singapore, but it's one of my favorite places. And there's a new regulation in Singapore that says that basically every building has to be net zero. And if you look at the buildings around Singapore, there's all this green, but it's not only built around the building to try to consume the carbon dioxide produced by the building. It's on every layer of the building, plants and greens and everything, so
Up
that
top, yeah.
the building can be net zero. It's really amazing.
Yeah, as long as you take back whatever you put in, or vice versa, right?
Mm-hmm. That is the whole idea of eliminating greenhouse gases. And carbon dioxide is the biggest greenhouse gas, but there's a whole list of greenhouse gases. There's methane, there's nitrous oxide, hydrofluorocarbons, and sulfur, hexafluoride, nitrogen, trifluorides. There are all these gases that are a part of the manufacturing process that it's important that if you you trap them and you store them and then you process them. And if you can't, you take other actions to try to reduce what has been contributed into the atmosphere.
Right. And then don't forget PFAs and other forever chemicals, right?
Mm-hmm. That is true.
So it's a delicate balancing act for a public company who has to be responsible to their shareholders as well as wanting to be responsible stewards for the environment. And there is enough of a crossover, at least let's say last couple decades or so, there is enough of a crossover where executives are starting to say sustainability is good business. We are finding ways to be more efficient. We are finding ways to use less to get more. And so it's a good trend. And we actually have some real world examples, right?
Oh, definitely. A company that has been very, very active in demonstrating sustainability through their action is Patagonia.
Yep.
Patagonia not only is a source for brand new stuff, but they also work very hard to recycle materials. They have a repair and reuse. They're just not taking things and throwing them out. And that is a very, very big action of a retailer that can demonstrate that, yes, they want to generate revenue, but they also want to respect the environment that they want to generate revenue. Another example is Unilever. Unilever has a plan to reduce their footprint, their environmental footprint, that is, and make sure that they are reducing their waste, reducing what they contribute to the environment, make sure they're not impacting their environment around them, and also they are reporting on this and measuring this. And quite honestly, that's, I think, very similar to what we do here over at Microchip. We've made a commitment to be net zero in greenhouse gases by 2040. We've implemented a Microchip 360 sustainability program that talks about environment, social governance, and product sustainability. And we publish a report on a yearly basis. We show the progress we have made from year to year on it. So it's not just putting up an ESG website. It is, if you will, an annual report on sustainability that has hard measured facts about it. And I have worked with it for the last 2-3 years, and we definitely have made progress. We've made progress in reducing our energy consumption. We've made progress in reducing our wastewater. We've made progress in the greenhouse gases that we are emitting into the environment.
Yeah, no, I've helped that team work on that report every year. It's a pretty sizable report, and it's getting bigger and bigger every year. But they do
It reminds me of an annual report. It's so big.
It is. It's designed for the shareholders, but it's also designed for employees and for prospective employees. Anybody that wants to come work at Microchip, they can see the efforts that we're making in real sustainability and reduction of water, reduction of electricity usage. How can we recycle a lot of what we do? One of our favorite claims to fame is there's a little lake next to, I think, one of our factories in Thailand that will be completely covered in solar panels. And by doing that, go ahead.
No, I was going to say, we've not only done that, what impresses me about the report, and a lot of people don't know this, but we have a contest every year for people to contribute their thoughts on it, either through words or through pictures. And all the pictures in the report are things that our employees have done. So we're not only saying sustainability within one little team, we are talking throughout the entire company. And we're saying, hey, we want this to be one of our base ethos of the company. And we want to make sure that everybody is involved. That always impressed me.
I think this is the third year that we did the photo contest. And so if you look at Microchip's sustainability report, you'll see an employee name and a location of where they were and the picture that they took. And you're right, it does reflect our ethos of sustainability and environmental stewardship. Where I was going with the Thailand thing is we put solar panels over this body of water next to the factory, and it serves a dual purpose. One, it saves the water from being evaporated. Two, it is a solar panel array. But because the solar panels are there, it protects the groundwater and it protects the environment for the wildlife there. So the birds don't have to move. They can actually maintain the ecological preserve while taking advantage of that square footage area. And so I thought that was that's a big a win all around, I guess I would say.
You know, when you come and visit me over here in Israel, I will show you something that's pretty amazing for us.
Yeah?
98% of hot water heating in Israel is all done through solar panels.
That's amazing.
It turns out that the most efficient thing you can do with solar energy is actually heat hot water. So we all have hot water heaters on our roofs with solar panels. There's a pump that pumps the water through the hot water through the panels all day long. The hot water heaters or the storage tanks on the hot water heaters are insulated. So when it gets cold at night, it's going down to freezing in Jerusalem where I live this week.
Right.
And, it still maintains the hot water for the entire night. And if you have a rainy day, there is a switch in your house where you can turn on the electric. I think I've used it 5 times this year.
Wow. That's a real effort. That's great to hear.
One of my fraternity brothers that worked in a power generation plant actually told me the most efficient use that you can have of solar power is heating hot water.
Yeah. So out here in Phoenix, people do it for their pool. They'll hook up solar panels to an electric heater. It's not very common, but it's not unheard of.
We had that in California too when I lived there too.
So let's get back into what we were talking about. So that's real measurement. You've got a recirculation pump with solar panels that are keeping the water hot, but there's also some key differences between kind of the world of press releases and media relations and then what real impact is. And you kind of touched on it before. It has to do with actually sharing and being transparent about the data. Are there other things that are important to actually making a real sustainability push?
Well, I think that, the key, and especially I'm involved in this on the energy distribution side, is how you distribute the energy. I'm a part of what we call Power over Ethernet. The Power over Ethernet business unit at Microchip was actually the pioneer. It was originally a company called Power Design. And in 1988, they came up with something called Power over Ethernet to allow IP phones to be powered from the same Ethernet cable that is connecting it to the network. And when you look at the approach to Power over Ethernet as opposed to plugging in your cell phone or something, Power over Ethernet says, I'm not going to deliver power until there's a request made from a device. And once that request is made, it's going to tell me how much power it wants. Power over Ethernet breaks it up into 8 classes. It can deliver from as low as 4 watts or as high as 90 watts and gradients in between. And then also, if the power is no longer needed, or if there is an interruption on the line, then we stop delivering power. So I think that there is beginning to look at the way that we are using things such as power to be more economical. I'm sure you're aware that the DOE has come up with a program called Energy Star. And Energy Star says how much power can be consumed if the power supply is in a no load situation. In other words, you've plugged your charger in to the plug, but you haven't hooked up your cell phone to it yet. It's still consuming some power, and
That's that
Energy Star
vampire
is
power,
saying,
right?
that's it. And what happens is, they're trying to make standards for this. Well, and power over Ethernet goes one better and goes back all the way to 1988, and it won't deliver power until a request is made. There's some power consumed by monitoring on the line, but it is minimal power. And then it's only delivered as much power as requested, and only delivered power for as long as it's requested. Once it's requested, no longer needed, it turns off.
Yeah, so we had a previous episode that I think released in December of 24. We talked to Dr. Kevin Spear from the Silicon Carbide Business Unit. His was about omnidirectional power grids. And I think most people don't realize that power goes one way. So it's generated at the power plant, it gets sent down the line, it gets converted, it gets managed, there was a word for it that as it's being brought from the power plant down to your business, down to the 110, 220 volts kind of accessible power range, a lot of it's lost, but it's only pushed one direction. So it never comes back. So part of what you're talking about is that power is there. And if your device is not managing how much it's requesting, it'll just keep pushing power to it. Do I have that correct?
Yes, definitely. It's interesting, just on a slight deviation, as more and more people are putting power onto their solar panels onto their roofs of their houses or in their backyards, or things, the energy grid has to be reimagined so that these people can deliver back into the energy grid instead of it being unidirectional.
Yeah, now you have a push-pull relationship. Yeah, so can we dig into vampire power a little bit? Because I think there's some things that people probably don't understand. If you have a remote control, it's constantly talking to the television to make sure that it's responsive when you actually do push the button. So it is sucking power out of the batteries in the remote, and the TV is still drawing power from the wall to make sure that it's alive and ready to go when you push on the remote.
That is very true. If you look at most of the devices in our house today, most of the devices not only are in a ready state to consume power, but most of the devices are converting that power from AC, which is delivered to the house, to DC to run the device. Right. I've got two screens on my desk. I've got a laptop on my desk. I've got a few more things on my desk. They're all using DC power, but when I plug it into the wall, it's AC power. So there's a conversion loss in that. And then it's sitting there ready, whether or not, it's very fancy screens. When it's not used, they turn off and they go dark. But as soon as I touch a button, that goes on. That means there is something happening within the device to say, did somebody touch a button? That has to consume some power. And that vampire power is in every device that we have today.
Right. Your refrigerator is kind of self-explanatory. It's constantly working because it wants to keep your food cold. And your air conditioner or your heater could be working constantly in order to manage the temperature in the house. But I think people don't realize that every single thing in your house that's plugged into the wall, if it's not managed, is actively drawing power on a regular basis.
Yes, that's very true. And that's some people estimate as high as that could be consuming as much as 20% of the power. I think that's a high estimate, but I would say at least 5% of the power is definitely being lost to vampire power as a minimum. Well, you talk about standards, like I believe California is saying by a certain date, 50% of the fleet has to be electrical. You wonder how the power grid has got to become more efficient to handle that charging all those cars. And if we got rid of some of that waste, that would be a good way to save some of that power, that we could use it better.
Right. That's kind of what brings us into a scenario like last mile power. So in a residential home, you may or may not have very many devices that are powered by Ethernet. But once you get into a business or into kind of a large commercial structure like a hotel, you're going to have a lot of opportunities for power over Ethernet, right?
So that's very, very interesting. Back, I think it was 10, 15 years ago, there was a hotel that was retrofit in, I believe it was Dallas. It's called the Sinclair Hotel today.
Yep.
And what they did was they retrofit as much as they can through power over Ethernet because it was a much more efficient way of delivering the power. And, they did things that you would expect them to do. They did things such as the phones, the TVs, even the lighting. It can all be done through power over Ethernet. But they did things that you may or may not expect. They put features on the windows, treatments on the windows, so that if it was getting too hot because of sunlight, they could put shade in the room, or they could open it to get it hotter. Those motors that controlled all that were power over Ethernet. The mini refrigerators that they put in were actually power over Ethernet. We had an engineer many years ago in Microchip who converted his little mini fridge to power over Ethernet. Now you can actually find power over Ethernet fridges. But they also redesigned some devices. You think of an iron. An iron has to consume a lot of electricity to get very, very hot. Well, an iron sits there all day not being used and then is maybe used for an hour. So they redesigned the iron so that there was a big battery in it and it would charge on the stand until it was full, and then it would stop charging. And then at that point, what happens is you could take it off the stand and you could use it instead of having a plugged-in iron all the time. So they attempted to make as many things as they could efficient, and power over Ethernet was one of the major drivers of that. But even today now, there are other hotels that are working on it. What was the name of it? The one in Connecticut. Do you remember the name? There's a hotel in Connecticut.
No, I can pull it up because I think it's in our notes, and we might actually talk about it in our next conversation. But it's not a one-off. So the Sinclair and I'm looking at the sinclairhotel.com. It's a boutique hotel in downtown Fort Worth, and they've got an actual technology page, which I think we might throw up in the show notes. There's some really, really interesting things we're doing here. First building in the world to replace a diesel generator and backup power source with a lithium-ion battery pack. Deployment of Cisco digital building switches in each room to replace regular high-voltage electricity and power in-room technology. Fiber GPON deployment for blazing fast internet. Wallpaper televisions. All kinds of fun stuff. I mean, they're really future forward in terms of that, of not just having a wonderful experience, but everything that you're talking about in terms of saving and reusing power. And the great part about Ethernet is it's Ethernet all over the world, right?
There is Ethernet all over the world. The thing about Ethernet today is that only 20% of Ethernet switches can provide power. So that's where devices that we help design and make, called midspans or injectors, that can add a power to the line once it's there. And even the switches today, only about 50% of the switches that are sold today are providing power because they cost a little more. And even on a powered switch, there's not enough power to give to put full power on every port. So there are devices to supplement and add onto the line. And because these devices and the power consumption is much more efficient, we are seeing more and more devices being created. The iron is just an example of what they did, but today printers are being powered by power over Ethernet. Just about everything that you can think of, the sensors, the thermostats, everything in your room. A couple of years ago, I did a coffee break. And it was the end of the year, and we featured all the devices. Yeah, that's it. The New Year's Eve party episode. So we featured all the devices that were being built using power over Ethernet these days. Originally, the three main devices that were used, and these are commercial devices, were wireless access points, IP cameras, and IP phones. But literally today, there are hundreds and hundreds of things. Kiosks, POS systems, again, commercial systems, but displays, TVs. There are hundreds of devices nowadays that are beginning to use power over Ethernet. Though I find it interesting, a lot of the places where they're using power over Ethernet are in retrofits today. I think it's just beginning to become a factor in new construction. There are still a few challenges, if you will say, to make it efficient for everything. One of the biggest ones is lighting. Because power over Ethernet has very definite standards of how much voltage, how much wattage that you're delivering. And if you look at light designers, each light has a different power profile on it. So you basically have to have a little bit of a converter until you get standardization among some of the LED light manufacturers that can just consume power over Ethernet. But we're heading there right now today.
Yeah. I mean, the fact that you now have consumer appliances in that category, that you can send data as well as power, it just seems, other than the economical argument, it just seems more efficient.
Well, that's a very, very good point. PoE enables people to not only provide the power, but because it's over an Ethernet cable, they can share the data. And even if it's a device that doesn't need data, the device can report back to the host what it is doing, and we can do things like preventative maintenance or predictive maintenance to say when something might fail that we might need to change it before it does fail.
Yeah, and predictive maintenance is kind of the holy grail of product support, is can you be there before it breaks rather than have to wait on a repair technician to come out?
Definitely.
So as we kind of wind down our conversation here, Alan, I'd like it if we could touch on Class 4 fault managed power, because that's kind of one of the key things here when we're talking about Energy Star, which I want to get to in our next conversation. Can you touch briefly on Class 4 fault managed power and what that is?
So there is a new power classification that was just approved by the National Electric Code. The National Electric Code is actually a fire code that, is standards that people have to conform to. It's a U.S. standard, but it's actually very much followed very much around the world. So power over Ethernet is called Class 2 power. Okay. That means it can only go up to a maximum of 100 watts. Because it is low, it is considered low power. It's not a danger to hurt somebody. It's not a danger to create a fire. You don't have to put it through a conduit when installing it. You don't have to put it. You don't have to have a licensed electrician to install it.
Right.
Well, there are limitations on that. One of the limitations is Ethernet itself. An Ethernet cable is only rated to deliver a signal and power over 100 meters. If you're starting with delivering 90 watts at the source, it only becomes 71, 72 watts after 100 meters. So, if you went 200, 300 meters, obviously there's a power loss along the line, and eventually that will mean that it's not becoming power efficient. So what happened is some innovative companies came up with this concept of almost digital power. It is pulses, but they are pulses of direct current, and they can sustain their power levels further, and you can go much further than 100 meters. So what's happening is they've created this new standard called Class 4 fault managed power, and this is, again, safe power, but it can go up to a much higher power level, and it can go much further. And because of that, if you're delivering power to a building, you can deliver it through AC, since that's the most efficient. Instead of having a conversion on the endpoint, every place that you go, you convert in one location. You distribute it through fault managed power, but most devices can't handle fault managed power. But since fault managed power is a DC-like power, it is very easily converted to power over Ethernet for the last mile, if you will, to distribute it and put it to the device. And a lot of these, for example, the Sinclair Hotel actually uses this technology. They used this technology before it was a standard, and they are now that it is a standard, it's being looked at. And I think that's another thing with new construction. Now that there is a standard to build to, they can go with new construction and say, yeah, this seems like a good way to go. But it's safe power. You can hold the power in your line. It won't hurt you. There's intelligence behind the power. And it is also a power that can go a lot further, but still maintain, high power levels.
All in the name of efficiency and sustainability.
Yep. And
This is great, Alan.
I think we're only at the start of finding out these new innovative things. I don't think a new power class has been added in many, many years. I didn't check that out, but before this, there were 3 classes of power. And now that we have a 4th class of power, that's great. But I don't think that new standards were added for many years. But I think we're going to see innovation accelerate over time as people become more aware. Vampire power, energy loss due to conversions, these things. I think we're going to see a lot of innovation invested into this to help us so that the power grid that is going to have more and more demand as time goes on can handle it, not only through producing more power through the grid and having the grid bidirectional, but also by having devices to be much more energy efficient and home designs, office designs, all that.
Yeah, one of the key themes that have run through this entire podcast, and we go off in different areas because we want to explore as much of the technology as possible. One of the key themes we keep coming back to is we're going to need more power as we continue to digitize everything around us, as we go into electric vehicles, as we get into more power consumption and things like data centers. There is going to be a need for more power. And it's pretty clear the way we generate and manage power now could definitely use a rethink. So things like class 4 is wonderful. Things like omnidirectional grids, a lot of the things that we're talking about. And I think a little emphasis on last mile power is a good thing to keep people aware of what happens once it finally gets to where you are. What could you be doing to better manage your own power, not just for sustainability's sake, but to lower your power bill?
You remind me of when I went to university back in the late 70s, early 80s, not to date myself a little bit there, but what happened was my university was one of the first universities to require freshmen to purchase a computer. Ooh. And there were no laptops then, and luggables weren't even out from Compaq yet. You had to purchase a desktop computer.
You're talking about a tower and a monitor. Yep.
And not only a monitor, it was CRT. It wasn't, LED or anything like that.
Yeah, the big brick. Yep.
And, and in my fraternity house, which was built around the turn of the century in the 1800s, it was a beautiful, beautiful building. There just wasn't enough power because every room had a refrigerator. We now had electric hair dryers. And now we're adding a computer in every room, and they don't take up as much power as the refrigerator and the electric hairdryer, but every incremental thing was adding to the load on that. They had to rip out the entire wiring of the building and replace it because it just couldn't handle it. And the thing that I see accelerating is the number of devices that can consume power and what we can do. When I was going to school, there were no cell phones. Okay, so you didn't have to have a charger for your cell phone there. Mm-hmm. There were no laptops. There were no tablets. There were no, there were no, wireless headphones that you needed to recharge in the night. There are hundreds of devices. Elderly parents these days wear devices around their neck in case they fall and they slip. All these have to be charged, and all these need to exchange information on a regular basis. And with what we're seeing is innovation is leading to higher power consumption, and now what we have to, or higher power demand, and now what we're seeing as a reaction to that is we need to get efficient with the way that we are consuming that power so that we have enough power to go around.
I think that's a great place to end it, and we'll get into that in our next conversation. Alan, thank you so much for coming back to the show. This was a great discussion. Alan Zwierin is Senior Product Marketing Manager at Microchip Technology, specializing in power over Ethernet solutions. He joins us today from Tel Aviv, Israel. Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.